to estimate the value of beta, we need to minimize the sum of. Now this is an old video. This was an 18 minutes odd video which I have divided into two parts. The first part is the part 8 already uploaded today, and this is the part 9 which is the same video which I had uploaded a long back with part 8, full part 8. So this is part 8 divided into part 8 and part 9, and this part will cover the estimation of beta. The new part 8 is the assumptions, and this is the estimation part. Now the problem here is I just wanted to make a small bit of clarification. I have loosely used residuals and errors interchangeably, but they are not the same. But the rest of the derivation doesn't suffer due to this notational issue. So I'll start the video now. Minimize the sum of squared errors, the usual thing which we did in the simple case too. And in this case, what is error? Error, E is equal to Y minus capital X beta. So we need to minimize the sum of squared errors, but there is a catch. This is not a scalar quantity. This E is a T cross 1 matrix or a vector. So this also is T cross 1. So how do you minimize the sum of squared errors, which is required by the least squares criterion? So if you recall a bit of linear algebra, E transpose into E would give you a scalar quantity. Now you need to understand why. E has a dimension of T cross 1. So the transpose of E would have a dimension of 1 cross T. So if you multiply them, it will have a dimension of 1 cross 1, which is a scalar quantity. So if I find E transpose E, it will give me a scalar quantity. Now what is that scalar quantity? This is E transpose. This is E. Let's find out E transpose E. E transpose E is equal to E1 into E1 plus E2 into E2 dot 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 plus ET into ET, because that is how you multiply two matrices, which will give you, lo and behold, sum of squared errors. And this is what we need to minimize, which means we need to minimize this, where E is this quantity. So I'll come again. E is this. E transpose E is sum of squared errors, and this is the quantity which we need to minimize, or rather this. So let's proceed with minimizing E transpose E, where E is Y minus X beta. We can represent E transpose E as this expression, and if we take the transpose inside the bracket, we will get this. The reason being, C D transpose is equal to D transpose C transpose, which means if you get transpose inside, you have to flip it around when you are multiplying two matrices. So over here also, transpose gets inside Y comfortably, but when it gets inside here, there are two matrices, so you need to flip it around. This is equal to this, and if you look at these two expressions, they are actually the same. This is transpose of this, and this are scalar quantities. Why? This guy over here is B transpose, and B is of dimension k cross 1. So this is of dimension 1 cross k. X is of dimension t cross k. So this is of dimension k cross t. And Y is of dimension t cross 1. So this is same, 1 cross 1. You can also look for the dimension of this. This is of dimension k cross 1, This is of dimension t cross k, and this is of dimension 1 cross t. So again, same, you have 1 cross 1. So essentially these two guys are same. So we will club them and simplify this expression, as these two quantities are scalar and transpose of each other. Now we have got a simplified version of E transpose E, and we need to minimize this. And in order to minimize this, we will need to find the first order conditions. Minimize. For that, we need to find the first order conditions. So let's proceed to the first order conditions. To minimize this, or to find the first order condition, you need to differentiate this and put to 0. Now obviously this expression is a kind of matrix expression and it involves a lot of matrices, so you cannot differentiate it in a normal way. So we'll need to resort to how to differentiate matrices, but I will not go through those steps because that is not the point of this lecture. So I've reserved those segments for linear algebra lectures. So in linear algebra lectures, I may go on to tell you how to differentiate when you have matrices in your expression. So let's skip to the next steps. Differentiation is done with respect to beta, and this has no beta. Only these two terms will give you some non-zero quantity. So if you differentiate this quantity with respect to beta to find out the first order condition, you will be getting, if you compare these two expressions, this was having no beta, so it goes to 0. This had a beta transpose that vanishes away, and this had a beta transpose beta, so beta transpose vanishes away. And as you have beta transpose into beta, so it will definitely give you a kind of a second degree expression. That's why a 2 appears here. That is a kind of a rough idea I can give you at this point of time, and more on the differentiation part in the linear algebra lectures. So if we have reached this first order condition, this is also known as normal equation. So let's simplify this normal equation further. After this stage, you need to find out beta. But remember, we are estimating beta. So we will not get beta, we will get beta hat. So this is the normal equation which you will find out in standard textbooks or in any kind of material on econometrics. So if we need to find out beta hat, we need to get rid of this quantity. Let's multiply this with x transpose x inverse. So if we multiply this with x transpose x inverse in this side, this will vanish away because inverse of a matrix into that matrix is identity matrix. But we need to multiply that inverse matrix here also to the left of this quantity. So we will be getting beta hat is equal to x transpose x inverse x transpose y. Now, if you remember our assumption on the determinant of x transpose x, it had to be non-zero, and now you can understand why. If the determinant of x transpose x is not non-zero, then you cannot find the inverse of x transpose x. And if you cannot find the inverse of x transpose x, then you cannot find out the beta hat value or the estimate for beta. Hence, this is the estimate for beta or beta hat, and this is the normal equation which helped you to get the estimate for beta or beta hat, which is x transpose x inverse multiplied by x transpose into y. This is it for this lecture on econometrics, and I will be adding more lectures, or rather mini lectures, on the course I have done at the Indian Statistical Institute for my masters in quantitative economics. So do not forget to keep checking this channel, and a better way would be to subscribe and press the bell icon And if you like this video, why don't you give it a thumbs up so that I know it. And you can watch my other videos playing around here by clicking on these video links. Bye bye.